Hello friends, in this video we are going to discuss about ion acoustic wave. Suppose we have this is a plasma ion. Suppose we have these ions and they are surrounded by electrons. We have already studied the Dewey shielding, isn't it? Positive ions are surrounded by electrons. Now you see these are the ions. Suppose as these are charged particles, they can interact via electromagnetic field at a long distance. So here you see, suppose this is these ions will interact with neighboring ions. They will repel each other. We know similar kind of charge used to repel each other, and then these ions will be shifted to next neighboring ions this way. Then again these columns will repel each other, okay, then repel each other, then these ions, this column of ions will be shifted, and this left hand side here you see this column of ions also shifted to original position again, okay. So we will have a pattern of compression rarefaction. Okay, this is rarefaction, and then again we will get compression, like sound wave. It's a longitudinal wave. So this way we will obtain compression, rarefaction, and compression again. In this way, the ion wave will propagate like sound wave. It is a longitudinal wave. So hope you have understood this, how it is formed. Here you see, in absence of magnetic field, so in absence of magnetic field, the ion fluid equation, okay, that means the equation of motion, it can be written as ion fluid equation when B is equal to 0. Magnetic field is not applied here, then it is given by m and capital M, mass of ions, you can say del V I by del T. So V I suffix I for ions, okay, then V I dot del into V I is equal to, so here it will be E. Now it will be positive E because of positive charge of ions into E, which is electric field, minus grade P. This is pressure gradient. Now here magnetic field is absent, so that's why in that case this is the equation of motion for ion fluid plasma. Now we know that electric field is given by negative potentials, gradient of negative potential minus del phi. So therefore this equation becomes m n del T plus V I dot del into V I. So if you replace this E by minus del phi, then what you will get? Then we will get minus E and phi minus, and from equation of state, from equation of state, so in lecture 1 in lecture 10 I have already shown how to derive this equation, lecture 10. So I will provide the link of that lecture in description box, okay. So we have got that this relation from equation of state. grade P is equal to gamma Kb, Kb, which is Boltzmann constant, T grade N. Okay, Kb is Boltzmann constant. Boltzmann constant. So, if we use this relation here, then what will happen? So, here we will write instead of gamma, gamma I and Ti ion temperature. So, and then using this value here we will get gamma Kb Ti grade N. So, this is suppose equation number 1. Now, so when we have studied fluid drift parallel to B field, in the lecture, I think lecture 13, in lecture 13. So, we have got Boltzmann relation, okay, Boltzmann relation. And what was that? That was Ne is equal to N naught exponential E phi 1 K T E. And so, here number of this is plasma density N naught at equilibrium position, okay, at equilibrium condition. Now, you see, if you expand this by Taylor expansion using, then you will get N naught exponential, sorry, not the exponential. If we expand this, then we will get 1 plus E phi 1 K T E, and we will get more terms, higher order terms. We will neglect those terms. So, I have not written those terms here too. So, now by linearizing, so how to apply the linearization. So, I have already explained in lecture 15. So, link of that video also given in the description box. So, hope you will watch. So, linearizing equation number 2 and ignoring the higher order terms. So, we get the perturbation in density of electrons is, so let me scroll down the page, N1 is equal to N naught E psi 1 K B T E. So here you see, so write here Kb, okay, instead of K write Kb, Boltzmann constant Kb, okay. So this is equation number 3, okay. So here number density, this is N naught is density in equilibrium, plasma density of equilibrium plasma, and when it is in equilibrium, then phi naught is equal to 0, E naught will be also equal to 0, and phi is equal to then phi 1 and E is equal to E1. Okay. So now if we apply the linearization in equation number 1, in this equation here you see. So if we apply the linearization condition in this equation number 1, then what we will get? So applying linearization, in equation number 1, and also we can replace del del t by minus I omega, replacing del del t by minus omega and del by I k. So these things already discussed in lecture 15. Okay, how to replace those? We have, so minus I omega capital M n naught V I 1 minus E naught I k phi 1 gamma I k b t I k n 1. So you may think or you may be confused that initially I have written only V I in the equation, now I am writing V 1 V I 1. So you may think why it is, because you see, so when we have applied when we used to apply linearization condition, we used to replace n by n naught plus n 1, v by v naught plus v 1, e by e naught plus e 1, isn't it? So as I have skipped this part, as we have already discussed the linearization method in lecture 15, so I have not shown these things here. So now you see, this is suppose equation number, so let me give it equation number 4. This is equation number 4. Now again, if we use the same if we use the linearization condition in continuity equation and replacing the del del t minus I omega and del by I k, then we will get linearizing equation of continuity. We get, so what we get, I omega n 1 is equal to n naught I k v I 1 and which implies from this we can have n 1 is equal to n naught k v I 1 by omega. So this is equation number 5. So here you can see we have simplified this, this to I cancel, and then we have got this. So yes, okay. Now from equation 3 and 5, if you compare these two equations, from equation number 3 and equation number 5, if you compare these two, then you will get here you see left hand sides are same, so right hand sides must be equal, and from equation number 3 and 5. From equation number 3 and 5. So what we will have, get this part here you see is equal to this right hand side of 3 must be equal to right hand side of 5, as their left hand sides are equal. Okay, then what we will get, so this implies n naught e phi 1 sorry E phi 1 by K B T E for electron temperature T E we will write, then N naught K V I, okay, K V I 1 by E omega, okay, sorry, not E omega, omega only. So this is the right hand side of equation number 5 and equation number 3. So here N naught cancel, then what we will get? So from here we will get phi 1 is equal to, so let me write here, here we will get, after simplification, phi 1 is equal to K into K B V I 1 T E by E omega, and this is suppose equation number 6. This is equation number 6. Now if you use these equations, if you use the value of N1 and phi 1 in equation number 4, if you use this value you have obtained in equation number 5 and equation number 6 in equation number 4, then what you will get? Now using equation number 5 and equation number 6 in equation number 4 is equal, this implies minus I omega m n naught V I 1 is equal to minus E n naught I k into K B sorry K B T E V I 1 by E omega minus gamma I K B T I into K n naught K V I 1 by omega, okay, omega. So here you can see this value is put here, this N1 is replaced by this value, and this phi 1 is replaced by this one, and doing so we have got this relation, okay. So now let me scroll down please, okay. From here what we can find? Now you can see here that this I and here this I cancels, then also we can cancel N naught, here also N naught, and also we can cancel VI1, okay. Then what we will get? So if you multiply both sides, here this DC cancel. So if you multiply both sides by omega, then you will get minus omega. If you multiply both sides by minus omega, then you will get omega square, and if you divide both sides by capital M also, then you will get K B K square T E by capital M plus gamma K B into K square T I by capital M. So now let us take K square common, then you will get K B T E by capital M plus gamma I K B T I by capital M, and which gives omega by K square. If you remove the squares, then you have to take square roots, K B T E by M plus gamma K B T I by capital M. This is dispersion relation for ions. So I hope you have understood these topics, and if you have, then please subscribe my channel if you are new to my channel, and if you like my videos, then share with your friends. Thank you for watching.